Lesson 1.5. So today we're going to talk about conditional statements. This is, again, beginning of proofs. We're still at the beginning stages. So I'm going to jump to the Explore and Reason. Okay, it says if-then statements show a cause and effect. The table shows some if-then statements. So if it's raining, then it's spring. So we're going to determine if these actually cause. Does the rain cause spring to happen? Is it always true? Is it sometimes true? Could you change it? So it says determine whether each effect is always true for the given cause or is not necessarily true for the given cause. For the effects that are not necessarily true, how could we change it to make it always true? So maybe just pick one or two and decide. So if x and y are whole numbers, then their difference, x minus y, is a whole number. So is that sometimes true, always true? Does it even affect each other? So you're going to go through these and maybe pick a couple and write about them here. Okay? And there's some relationships you can talk about. You have the word hypothesis and conclusion in lots of classes. Actually, hypothesis and conclusion, and we have those in math as well. So you can write in that journal if you'd like. Okay, here it is. A conditional statement is an if-then. If I get my jobs done, then I can go to the movies. Or if I do my homework, then I will get good grades. So those are if-then statements. One affects the other. So a conditional statement is if-then. It relates a hypothesis, the part that follows if I get my work done, that's the hypothesis, then I can go to the movies, that's the conclusion. And it's written like this: if P, then Q. So as we go through this, example 1, it says write a statement as a conditional. So you are going to take whatever sentence they give you and you're going to make it into an if-then statement. So it says you can register to vote if you are at least 18 years old. So there is an if in that sentence. You might have to rearrange it to make it be an if-then statement, but sometimes there won't be an if or then in the question at all. So you'll have to determine what the hypothesis is or what's causing that conclusion. And there's some more examples in here. Okay, and so you'll do that. Example 2 is about truth values. Some teachers are not teaching truth values, some are. So it says the truth value of this statement is true or false. So see how these trues are false, according to whether the statement is true or false. A truth table lists all possible combinations. So let's just use the example of me doing my jobs, I go to the movies. So if I do my jobs, I did them, like yes, I did, it's true, then I get to go to the movies. That's a true statement. Yeah, I did exactly what the statement said. So if I do my jobs and I don't get to go to the movies, that's false. That would be a false truth value because if I did my jobs, I'm supposed to be allowed to go to the movies. But if the conclusion is false, when the beginning part, the hypothesis is true, then the conditional is actually false. Okay, now these two are false. This is if I did not do my job. If I did not do my job, I can go to the movies. Have you ever been to the movies without doing your job? Yeah, you have, most likely. So that is true. Like it does happen. Sometimes I don't have to do a job to go to the movies. Okay, so it's true. And then the last one, if I don't do my job, I don't go to the movies, which totally makes sense. I didn't do anything, I don't get the reward. So those are the truth values, and you're going to determine some truth values for some certain statements in these examples. Okay, so I'm going to leave those to you. And you'll be asked some questions about truth values. And just think, if you do your jobs, then you get to go to the movies. Use that as an example to help answer those questions. I'm going to jump way down to the lesson. Here's some definitions. These definitions will come back, especially when we're doing proofs. So I want you to look at them, read through them. The converse. If I do my job, then I go to the movies. The converse. If I go to the movies, then I'll do my job. So the converse is just taking the conclusion, the hypothesis and the conclusion, and switching orders. That's all it is. Notice the Q is here and the P is there. Negation, it sounds like negative. It's exactly what it is. Negation is not. So not P, which means I'm not going to do my jobs. That's what that means. So not the hypothesis. Inverse is obtained by negating both the hypothesis and the conclusion. So I'm not doing my jobs, therefore I'm not going to the movie. So inverse. Okay, and contrapositive. So contrapositive is basically taking the inverse and the converse and putting them together. So first of all, the converse, it switches them. So the contrapositive has a switched order, and they're both going to be negative. So if I go to the movies, or if I do my job, then I go to the movies, switched. If I don't go to the movies, then I don't do my job. So it's totally switched around. And you can write a couple sentences and actually manipulate the sentences and move them around to try to get examples of contrapositives. Well, all of these actually. Okay, we're going to skip this for now, and I'm going to jump all the way to do you know how? Oh, biconditionals. Actually, let's stop here. So biconditionals. A biconditional is the combination of a conditional. So if I do my jobs, then I go to the movies, and the converse. If I go to the movies, then I do my jobs. So it combines them both as if they can only happen together. So I do my jobs if and only if I go to the movies. And I go to the movies if and only if I do my jobs. So it's like they both have to work together. So if I do my job, I go to the movie. True. If I do my job, I don't go to the movie. False. Okay, because that's not fair. I did my job. If I don't do my job, can I still go to the movies? I can't. So that would be false. So with this, it works both ways. So you have to have them work together. So where before the truth value, if I do my job, I go to the movies. If I didn't do my job, sometimes I do go to the movies. Okay, but in this truth value, it says if I don't do my job and I go to the movies, that is not allowed in a biconditional, because biconditional has to work both ways. Okay, now if I don't do my job, I don't go to the movies, that's true. Okay, so biconditionals work both ways, if and only if. And keep in mind, this takes a lot of time to grasp, so you might have to refer to these definitions a lot and the truth values. Keep jumping through. This is helping you identify biconditionals. It even has here's the conditional, here's the converse, and it kind of does it in a visual and words and symbols. So you can look at that a little bit better. And then we're going to go all the way to do you know how? And your teacher could have assigned you problems in between. I'm just jumping to the big stuff. So it says, write the following statement as a biconditional. Remember, biconditional is if and only if. So a prime number has only one and itself as factors. You would have to break it up so you could have something, if and only if, the other thing. So I don't want to give away too much. And there's several examples in here, all to do with Converse, conditionals, and just listen to your teacher to know which ones are going to be assigned. Okay, at the end of the lesson, you may or may not have assignments. That is totally up to your teacher. I hope this helped.